If you think about it, if I say what is the sine of or what angle has the sine of root 2 over 2, you guys could give me two different angles. You can give me 45 degrees or 135 degrees. Do you agree? So pi over 4 and 3 pi over 4. Both of those values are positive root 2 over 2, excuse me. So what happens here is that we change the parameters of where you're going to be looking. You're always going to be looking for your reference angle out of your first quadrant, but sometimes you might have to bounce it into a negative position. Here's what this looks like. When you're working with cosine, the two quadrants that give you the full gamut, if you will, of your cosine values between 0, or excuse me, between positive 1 and negative 1 are within quadrants 1 and 2. The inverse cosine will be defined between negative 1 and 1. Does that make sense? It can equal negative 1 and it can equal positive 1. So your inverse cosine will be defined somewhere within there. Also, that means it's defined between, instead of saying between 1 and negative 1, I can say pi, or I can say, I don't even want it, 0. Well, yeah. It's also talking between your negative pi's. All right, let me show you the better diagram.
Wait, I thought secant, cosecant, and cotangent were the conditions.
What I'm doing here is this, you're right, the secant is the inverse of cosine. But what I'm talking about here is what cosine of something gives me pi over 4. What is that angle? You did this before in right triangle trig, where you'd have theta here, and you had a 5 and an 8. You'd find theta by hitting the inverse cosine button. It's kind of the same idea, but we're using the special triangles to develop this. Again, the real reason that we've worked so hard on all of the trig functions. The reason why we spent so much time working on all these trig functions is hopefully this section is just going to be a piece of cake, especially the non-calculator part. The calculator part you guys will be able to do no problem. That's easy, very, very easy. Also, we're going to go back to 11 or 13.3 again for day 5 at some point to talk a little bit about the calculator problems they have in that as well. Probably combine those two to one lesson, which means we're basically done with trig. Well, it's chapter 13 stuff. My best guess as of right now would probably be next Thursday, so you guys know. My best guess would be next Thursday as far as any assessment, whether I'm thinking of maybe doing the test just over the calculator, non-calculator part stuff. Sines, cosine, law of sines, law of cosines, we've already taken care of that. I'm thinking leaning more, because we've worked very, very diligently through this stuff. But I'm going to reevaluate over the weekend and let you guys know at the beginning of next week. Yes, sir?
Can we just like...
I'll let you know. I'll let you know how much of everything will be on there. Okay. So yeah, what I'm saying here is that we're talking about theta for cosine. You're between 0 and pi, if you're going from here to here. And you're between 1 and negative 1 going this way as well. When you're talking about sines, the two quadrants are going to give you the sine values for positive and negative. I don't know how I got this thing out of order. Or when you're talking about the first and the fourth quadrant. Your inverse sine function is always going to give you something between 90 degrees up top and negative 90 degrees down here. They're all positive here, and they're negative down here. So you're saying it's between positive pi over 2 and negative pi over 2. Which means I can give an answer of what angle has an inverse sine of negative pi over 4. I can say that's negative 45 degrees, negative pi over 4, negative root 2 over 2, excuse me. I can say those things now. I don't have to get the coterminal positive. I can use the negative angle. Okay? I'm okay using negative angles here. And The last one then to worry about where it's being looked at is tangent. And the reason why we look at tangent in the first and the fourth quadrant is also, well, one of the main reasons is what is the tangent of 90 degrees? What's the tangent of pi over 2? What's the ordered pair right here? 0 and 1. So it's 0 and 1. The tangent at 0 and 1 would be 1 divided by 0. Do you agree? That's undefined, right? That's why it's between. It's not, it can never equal 90 degrees. It'll never equal pi over 2. All right? When we go to graph tangent, now, remember yesterday I showed you guys briefly what a graph of cosine is going to start to look like as you're walking around the circle? The tangent function, when we start to graph it, it's going to have asymptotes to it. Values that it'll never approach. That's what tangent will look like. It's a little bit weird versus the other ones. So again, tangents can just be between first and fourth quadrant. Again, when we base this off the triangle, you see how easy that is. Those numbers will pop off. Example. What angle has the sine, or what angle gives you, what angle's sine gives you root 3 over 2? What triangle is that? 30-60. So if I'm at a 30-60-90 triangle, which one of those angles gives me a sine of root 3 over 2?
Tangent.
What angle gives me the sine? 60 degrees gives me the sine of that, right?
Yeah.
So this is a positive value. So this needs to be a positive 60. So the answer is 60 degrees, or what's 60 degrees in radians? Pi over 3. That's how easy this is. Yeah? Remember, the inverse sine is asking you what angle gives you the sine.
Oh.
That's why I'm saying it as what angle has the sine, what angle gives the sine.
It's not saying that this is the cosine.
Correct, or not saying cosecant. Yeah, I know what you meant though. No, it's which angle gives you this value, okay? If it said which angle gives you the cosecant of 2, what angle gives you the cosecant of 2?
Cosecant of 2. Cosine 60.
30, very good. 30 degrees. Cosecant, remember cosecant is hypotenuse over opposite. When I'm in a 30, 60, 90 triangle, my hypotenuse is the 2, my opposite is 1 when I'm at 30 degrees. So the inverse cosecant would be of 2, it's 30 degrees, or pi over 6. Okay. What angle gives you the cosine of 2?
60.
Remember how cosine was defined? Cosine was defined between -1 and 1, right? Can I have a cosine of 2 of negative, or excuse me, can I have a cosine of 2?
Oh,
No.
That's it?
Yeah. Can't have it.
No.
Can you just write now?
Yes. If that's clear. Yeah. It's one of those little things that'll happen from time to time, because you start to think about in terms of how do you get the value of 2, that's usually with your 30, 60, 90, because you've got a 2 over here, the 1 and the root 3. And to get me a cosine of 2, there's nothing that, this is always a hypotenuse, so it's not possible. Does that make sense?
Yeah.
Good. What about the inverse tangent of -1? What triangle has the tangents of 1s and -1s?
45.
45s. So I know it's got to be a 45, 45, 90 triangle. But where is tangent negative? Which quadrants? 2 and 4. And tangents defined when we were doing the inverses in what 2 quadrants? So which quadrant should I be looking for? I should be looking at quadrant 4 here, because that's giving me a negative value. Now, does everybody agree that the inverse tangent of -1 is negative 45 degrees? Can I say that? What's negative 45 degrees in radians?
Over 4.
Negative pi over 4. Very good. So it's negative 45 or negative pi over 4. You okay?
I thought the second quadrant was also.
It is, but remember, I'm looking, when I'm graphing these, and this came up again last hour, when I'm graphing and I'm looking at where the tangent is a continuous positive to negative without that undefined jump, if I go from first to second, you're right, it is positive and negative, but what happens when I reach this spot? It's undefined, so it has an asymptote here, so it is no longer continuous between 0 to pi. It's discontinuous there. It does not continually have a value, okay?
So you're saying from 4 to 1 there isn't.
So when I'm between here to here, it's continuous. That's what I'm looking at. Does that make more sense? Since there's this asymptote jump, we don't look at it in 1 and 2. You'd want to, but you really can't. And that's, like I was saying, when we graph tangent eventually, it does this. This is pi over 2, this is, or negative pi over 2, and this is pi over 2, as it's going across. The distance between here is only continuous for pi. All right, and this is where we're headed. So, try a couple of those. Take a minute, see if you can figure those out. Don't use your sheet. See if you can do it in your, see if you can, I'll do some homework. All right. What triangle do you think you're working with if you're doing inverse tangent of root 3?
30, 60,
All right.
60.
So again, from yesterday, if you draw these out, which angle is going to give you the tangent of root 3? The 60. So that means your answer is 60 degrees, or, very good.
Do we have to write both of them?
Yeah, I want you guys to write both degrees and radians for these, please. Okay. Root 2 over 2, we should know this one off the top of our head. 45 or? Yay! Sine 1/2.
30.
Doesn't it feel good that you've learned and accomplished something this week?
Yeah, it actually does.
Inverse cosine, negative 1/2. Negative 60 or?
Negative pi over 3.
Negative. Or negative 2 pi over 6.
Yes, sir.
Can it be like that
Pi.
big angle? Can it, like since it's negative 60, can it be like a,
I know what you're talking about. You want it, if you're at negative 60, you're thinking about spinning around to 300?
yeah, could you like do that?
Well,
Or would you just write the negative 60?
oh, okay. I'm sorry, I'm thinking negative 60. Yes, here's what happens. And I let this one go last hour too, because I completely like, oh yeah, that's right. And then I realized, nope, Murphy, slow down, you're wrong. Again, cosine is defined between which two quadrants? 1 and 2, okay? Now, the cosine being negative will be in the second quadrant. So if we agree that this is going to be, this 60 degrees. Now, what we have to think about here is that means it has a reference angle of 60. What is that angle then? It's 120. This angle is 120 or 5 pi over 6. Oh, wait, no. It's 2 pi over 3. Yeah. Yeah, as soon as you said over 6, that means, no, that's a 30 degree. Yes.
That's
Again.
the answer is negative 60.
Again, cosine inverse is defined between first and second quadrant. If cosine is negative, it's in the second quadrant. The value that we were looking at had the 1/2. So that meant we were at our 30, 60, 90 triangle. Or was it 2? Yeah, 1/2. Okay. So the cosine of 60 is 1/2. When I'm placed in the second quadrant, that meant that my reference angle is the 60 degree, which puts me here, which means that the positive angle is 120. The cosine negatives will be the ones you have to slow down to reread. Sines and cosines, you're just bouncing above 0 or you're bouncing below 0 if you're positive and negative. Same thing with tangents, just above it or just below it. When you have the negative angle of cosine, you're between 90 and 180. You have to worry about that stuff there. You'll be subtracting that reference angle from 180. So your answer is 120 or 2 pi over 3. Yeah, it'd be 120. What's that? Yes, sir.
So for sine tangent, the other one just kind of have like a 120 angle.
No, you're gonna have you'll have positive or negative acute angles. Okay. That's the weird one. This is the one we just have to double check on. And you thought I would have remembered that from last hour when I did the same thing, but yeah. Maybe by 12th hour I'll get it right. Nah, probably not. I'll probably forget it anyway. So here's what I want you to do tonight. It's on page 795. It's these 8 problems. 795, 18 through 25, please. Page 795, 18 through 25. These are all inverse ones. Give me a degree and a radian, please. Just be careful with your cosines. Watch your cosines when they're negative, especially, okay? The other ones you should be all right with. All right?
Push the test back to Friday because that's holiday.
Yeah, I know.